Every vibe coder has experienced starting a Claude Code project and having it quickly turn into spaghetti code. Today, I'm going to introduce the 4-step process that transforms vibe coders into senior engineers. I'll also walk you through a Claude Code plugin to automate this 4-step process and demonstrate using it live on a real paying client project. By the end of this video, you'll never again find yourself in vibe code hell. The workflow and plugin I'm going to introduce today is called compound engineering, an agentic coding philosophy coined by the organization Every, whose online magazine and public AI building are really pushing forward the conversation of what's possible with agentic coding. Compound engineering breaks up agentic coding into a 4-step process. The first step is plan. In the plan step, you provide as much context as you can to your agentic coding tool about the feature you want built out or the analysis you want it to do. And then you have your agentic coding tool simply make a plan about how it's going to go about implementing this feature or analysis. In the plan step, you might ask it to study your code base, do some research on the wider internet about some concepts relevant to what it is that you want it to do, or research best practices as they apply to your project. Once you feel confident about the plan, you can move on to the next step, actually doing the work. From your perspective, this step is very easy. You just give your plan to the agent, it creates a to-do list, and then you step back as it goes through that list and does the work. There are nuances that help out, like giving the coding agent the ability to verify the outputs of its work, run tests, or check for type consistency in your code base. But generally, there isn't much to it. This is the point where if you've enabled YOLO mode, for example, you can simply grab a coffee, go for a walk, pet your dog, check your email, and just sit back for 15 minutes, 30 minutes. I've let it go on for an hour and a half while the coding agent goes through this big to-do list that it's created from your plan. Now, once the agent finishes its work, you're ready for the next step, review. Traditionally, in a fully human software development process, after one engineer finishes their feature, they would create a pull request asking the broader team if it's okay if this work they've done be merged into the main code base. And then another engineer or colleague would come in and review that work, and they would ask questions or make comments such as, that class or file is getting really big, why don't we split it up? Here you're allowing that function to take raw SQL. That's a major security problem. Or perhaps, are you sure you should use that library when we're already using this other one that does the same thing? Now, this review step can be done by AI itself. The typical way in which this review step is done is to create specialized subagents, each of whom have distinct philosophies of what kinds of things make for good code or a good project for whatever it is that you're doing, and then have a master agent which combines the reviews of all these individual subagents. It's this step more than any other that lets you go from vibe coder to senior engineer. You can, to a great extent, rely on the expertise embedded in the definition of these specialized subagents to help you review the work that you've initiated in the work step. Now, part of the review step is you yourself taking a look at the code and seeing if there's anything that smells a little bit weird, looks a little bit off, and working collaboratively with the coding agent to ask it questions of why did it do things that way? Or don't you think that this thing could be a little bit better if we did it some other way? However, if you're an inexperienced developer, for many very productive, very interesting AI applications, you can get very far without ever manually double and triple checking the work, and instead relying fully on the AI subagents to do the review step. Once the review is done and you've merged in your finalized feature or analysis, there remains one last step to the compound engineering process, and this is compounding. In the compound step, you and the coding agent jointly reflect on what was learned in the process of trying to implement whatever it is that you were trying to implement. And you document these learnings somewhere in your own codebase. In doing so, you give yourself the ability to remember what mistakes or learnings you had from the past or that coding agents made in the past. You give your teammates the ability to access those same learnings. And perhaps most importantly, you give future coding agents the ability to come into this fresh project and understand what was learned in the past from things that its cousins attempted to do in the past. And one thing that's very important is that you need to set up your plan step so that in the plan step, you have a phase where you are going back and accessing these learnings wherever they are written out to make sure that you're taking away whatever's most important from those prior learnings and embedding them back into your future plans. That's what really creates this sort of compound engineering loop where every single unit of engineering makes future ones a little bit better. By the way, if you're somebody like me who prefers reading tutorials to watching them, on my site, ai-mba.io, I have articles corresponding to every tutorial I've made about Claude Code or agentic coding more broadly. Additionally, if you've got any questions about compound engineering as you're watching this video or after you've watched it, in my Skool community, the AI MBA, we've got nearly 800 AI builders, business people, and academic researchers, a lot of economists who are working together to get to the frontier of agentic coding in their professions. So come join in and I'll be happy to answer any questions you have. I've got both of those links down in the description below, so definitely check them out. Now, coming back to compound engineering and hearing about this 4-step process, you might be thinking, this sounds nice, but how do I implement it? Do I need to reinvent this all from scratch? And the answer is absolutely not. Every has created a Claude Code plugin, also, surprise, surprise, called the Compound Engineering plugin, which takes this 4-step process and automates it so that you don't need to worry about how to best implement it. The plugin takes each of these 4 steps and gives you a convenient command, which you can use in Claude Code to implement that step. So if you want to implement a new feature for your software or some automation for your business or an extension to your academic paper, as your very first step, you just type into Claude Code \workflows:plan and give all the context about this new thing that you want Claude Code to do. You can type it out, you can point to particular files in the repository, or just trust that Claude Code will be able to do that itself. I usually just speak into the microphone using a speech-to-text tool called Whisperflow, but however you want to, just give the context to Claude Code. Now, once you're satisfied with the plan, which might be an iterative process that you go through in the Compound Engineering plugin, you simply type into the terminal \workflows:work and allow the coding agent to turn the plan into a to-do list that it simply executes one by one. When you want to review the work that was done, you can use \workflows:review to initiate reviews of the work by a large set of specialized subagents, each with their own distinct philosophies and particular details that they use to check the integrity of your codebase. And in the last step, \workflows:compound, Claude Code will take a look at the context of what's been discussed and experienced in your coding session, and then write out to a folder docs/solutions what was learned in this session. But how do we get compounding? Very importantly, the way that Every has defined the \workflows:plan command has a follow-up step called Deepen plan, in which Claude Code will spin up subagents corresponding to each learning which exists in this solutions directory and ask the subagents to assess whether these prior learnings apply in the context of the current plan. That gives us the compounding in compound engineering. Now, while Every has created this compound engineering plugin, this approach to compound engineering is not the only way to do it. There are other Claude Code plugins, as well as skills in other coding agents like Codex, with their own approaches to developing these sort of self-reinforcing improvement loops in the coding and software development process. Additionally, Every's compound engineering plugin itself is being developed very actively, so the way particular commands work and the way they all link together does change on a week-to-week basis. However, the particular loop of plan, work, review, compound is stable and is very important to internalize in thinking about how best to do your work overall and make the best out of agentic coding tools. So whether you want to go about this manually by just directing the coding agent in a particular way every time, or by making your own plugin, or by using compound engineering itself, Every's plugin, you are going to want to implement this loop. It really gets to the core of how these tools can best be used. Now I'm going to use the compound engineering plugin live to make an extension to a project that I'm doing right now for a real paying client. The tool I've created for this client is an email transformation tool. So what the client is able to do is put in an email that he likes and thinks is conceptually good, which is from a completely different context to his, and then is able to generate an email which has some of the same concepts and ideas. So this is like a German business coach, but then he can apply it to his setting where he's a veterinary coach for German dog owners. And he's got a thriving online coaching practice. So here's a generated email that I've created for him. Now, the approach that I had taken to this tool that I developed for my client was to scrape all his YouTube video subtitles, and from those YouTube video subtitles, extract his style preferences and veterinary concepts and use that to create a system prompt, which can then be combined with any email that my client puts in order to get out a version of that email that sort of fits his business. And if you want to be able to do this yourself, I really recommend this video where I reverse engineer a popular AI influencer's YouTube channel using exactly this technique and use that reverse engineering to apply to how I should make my own videos. Now, what the client wants is an extension to this. What he's described it to me is that the results we're getting are about a 6 out of 10. And before he actually sends out these marketing emails, he wants to get it to an 8 out of 10. And the way in which we're going to do this is that my client has come out with a book. And so that book is going to be a much better source of truth about his style preferences and veterinary concepts. So we're going to extract from his book some of the kind of like best ideas that we can get. Additionally, my client has given me a sort of haphazard in progress Excel spreadsheet of common symptoms mapped to common treatments that he would recommend to pet owners. And so, what I want to do is see if I can use compound engineering to either improve the prompt that we are giving in order to create these emails, or create some more agentic approach, which sort of iterates between looking at the Excel spreadsheet and the ideas from the book in a while loop in order to create the email. To be honest, I don't think I'm going to do that. It would be kind of complicated. And so instead, I'm just going to try to improve the prompt here by extracting text and ideas from the book as well as from the Excel spreadsheet. All right, so here's the book, which I guess, again, this is German. I really have no idea what it says, but it looks like there are 26 chapters. So one approach that we might take is to have a sub-agent doing some kind of analysis per chapter, though these chapters are also pretty short. And I see that this introduction part is kind of longer. Okay. So some thought needs to go into the best way to be able to extract structure of some sort to use for these emails. And then this is the Excel spreadsheet. I don't know what it's saying. Seems to be some mapping of symptoms to something or the other. Jesus, I really have no idea what these colors mean. It just looks like a total mess, to be honest. But we'll make our best guess at what it is with the use of these tools. So, all right. I want you to take a look at the following directory. In this directory, you're going to see a book by the doctor, and you'll also see a Excel sheet of some kind of mapping of symptoms to ideas or something. And what I want your help with is understanding like what the potential useful content is that's in here. Because my goal is to extend the quality of the emails that we're getting from the email transformation tool. However, the problem is that, one, I don't speak German, so I don't even know like what is in these things. I think that in the PDF, there's going to be a lot of irrelevant stuff that we're not going to want to use to improve the quality of our system prompt in Email Transformer. And also the Excel sheet, I think it's very messy. And again, I don't speak German, so I have no idea what's inside it. So what I'd like you to do is spin up some sub agents, maybe one for each of the PDF and the Excel sheet, give it the context of what our final goal is, which is of improving the prompt, like the system prompt, and have it create a markdown report for me, which it compiles to a PDF with Pandoc. And in this report, it should basically look at these items and give me an analysis in English of how we might be able to use um, what's in these resources to improve our system prompt. And the goal that like these sub agents should have is not to suggest the changes that we make to the system prompt or to even think they are capable of understanding like exactly how to use these resources to make the change. Instead, the goal is just to understand like what a potential strategy would be in terms of like, is this thing a total mess, or is there like stuff that we might be able to delegate to other sub agents to break up this task even more to like really get to our final outcome? That's kind of our goal. All right. So what I'm doing here right now is not explicitly part of the compound engineering step. You could think of it as like, I want to have a plan, but before I even like try to make the plan, I sort of still need some additional information. I don't even know what to tell the plan step Claude Code. Like, what should it look at? What should it ignore? And it might be able to figure out those things of its own accord. But a PDF, like a 300-page PDF, is pretty big and it's going to be pretty token heavy. So it's going to be a lot better if we have already done some work to extract or at least understand at a basic level what sorts of stuff is going to be relevant before even getting to the plan step. And so this could be your case as well. Let's say if you're an academic researcher who's trying to make use of compound engineering when you have hundreds of papers that you're taking as input. Or if you're a business owner who has a gigantic database of your meta ads over time and the inventory that you have and product photos or whatever, and you're trying to optimize all of this for your fashion D2C company. Like, when you're in those situations, you might want to spend some time thinking in your head before you even do some planning. And that's kind of what I'm doing here is I'm just doing some iterative investigation to understand what it is that I even have to work with before I start to make a plan. Okay, so right now we see that there's two sub agents at work. One is analyzing this German PDF book, and then the other one is analyzing this Excel symptom mapping. Now, one thing to remember is that any Claude Code agent has a limit of 200,000 tokens. And this one is just going to be taking up a ton of tokens because it's trying to get through that PDF. And so I know like a 200-page PDF is definitely going to be a problem. So we want to do some pre-processing on that PDF before we even get to the plan stage, maybe by extracting out the text or at least understanding what parts of the PDF are going to be useful and what parts of the PDF are not going to be useful. All right, so now we have a summary, and let's take a look. Data quality, very clean. Text extracts well. Structured content, highly useful content. Core metaphors, signature phrases. 3 disease triggers framework. 5 case studies, medication critique analogy. Content to avoid, anti-vax content. Okay. Let's keep going. Excel spreadsheets analysis, 3 sheets, 187 rows. Some sheets are clean, others are messy notes. Sheet 2 is immediately usable. Clean table mapping 24 natural remedies to pharmaceuticals. Sheet 1 intro column, 20 pre-written opening hooks in Franz's voice. First 30 rows of sheet 1, structured symptom cause mapping, not useful, stream of consciousness notes. Okay, very good. Let's start with just the PDF. If you were suggesting, like, I think that a good place to start is for the relevant parts of the PDF, we have sub-agents who are dedicated to only getting out exactly like the text of that section and writing it out somewhere. So I don't know what the best tool is, PDF Plumber, PDF grep, But the goal isn't to like paraphrase or summarize initially. I just want to have a sub agent who is like, there were some parts, I think like the intro, the biographical part, which I think you said weren't relevant. So I want like different sub agents to perhaps be dedicated to different page numbers and then write out to some location. And so that'll be good because text is a lot less heavy than PDFs are. And so that's a good initial data engineering step. And so if you were suggesting an initial set of subagents, what would you suggest? All right. So it's got for me 5 page ranges for 5 subagents to extract the text out from this PDF. So this is going to be a good sort of initial step that I would recommend to you guys too, if you're working with PDFs, is get the relevant text out, because the text itself is going to be much more efficient for analysis than a PDF is. Okay, so those 5 subagents completed, and we've now got 5 sets of extracted files. Let's take a look here. Whoops. All right, so now we have the raw text extracted from each of those pages, which is going to be much easier to work with for later coding agent. Great. If you were doing a similar sort of pre-preparatory step for the Excel sheet, what would you recommend? Okay, great. Spin up the 4 subagents. All right, so we now have 4 more subagents, which are kind of doing their thing. All right, so we now have 4 more subagents, which are kind of doing their thing. Sweet. Let's take a look at what was produced. So go in here. No, not that. All right, these look like possible intro hooks. This is some JSON of symptoms and causes. I guess some sorts of talking points. I don't really know. And these are, I guess, like products, use cases, and remedy. Okay. All right. Very good. So let's clear now. And now let's use compound engineering. So we'll do workflows/plan. Let me get in here. This directory contains a PDF and Excel spreadsheet corresponding to the doctor. It's a book which he has created about his philosophies on veterinary practice as relates to dogs. You don't need to look at either the book or the spreadsheet. We've already kind of extracted what is relevant from both and put it in here. We didn't extract everything. I had some sub-agents go through and look at like what was the most relevant bits to extract. Now, what I haven't mentioned is the purpose of this extraction. The purpose of this extraction is to help us improve the system prompt in the email transformer thing that we have right now. And so what I want to figure out is how to use this stuff that we have from the books, right, in order to create a better system prompt, like how to engineer it, and whether to kind of take an agentic approach or just fixing the system prompt. I veered more towards doing the latter. I think it's simpler. I just kind of want this to be done with. Yeah, let's plan on doing that. And like, what I could imagine having is a pretty long system prompt with an instruction that not all of it like needs to be used, but that the LLM, which is generating the email, can like think about what's appropriate to use. Yeah. Oh yeah. And also we should follow Anthropic's best practices on prompting, which you can read about here. All right, let's see how this works. So we are now in the plan stage of compound engineering. And what you can see is that compound engineering is setting off a bunch of different sub-agents. And so you may have been familiar with plan mode, which already exists in Claude Code. But what compound engineering does first is it sort of has an idea of what kind of sub-agents would be useful to have in a plan mode. Well, let's take a look at how the repo already works. Then let's take a look at like what best practices are for some of the things that we're thinking about doing. And then let's take a look at some of the frameworks that the repo seems to be using so that we have a clear understanding of how to use them. So that's what it's all doing right now. And so one thing that you can see is that we're using up a lot of tokens here, right? There's 118 there, 83.7 there. And so a consequence is going to be that if you're on the pro plan, you're going to run out of tokens like really quickly. And so for most people, I'm going to recommend you get on this max 100 plan, or you even get on the max 200, which is the one that I'm on. Because when you're using these subagents, it's like you're using 3 or 5 Claude codes all at the same time, and that's going to eat up a lot of token. So if you went here and looked at my usage in this last week, I've used up 80% of my potential usage in the week. That should last me, since I just have to last for 1.5 more days, but I do get pretty close even on that 200 a month plan. All right, so it's coming around to finalizing the plan. This has taken about 5 minutes, so it does take a while for it to do its research and come up with a plan. All right, so the plan is completed. It's here. We're going to take a look at it. But first, you can see that after you finish a plan, there are a few different options that come up. One is this Deepen plan option, which works best if you've been following the compounding approach in compound engineering. Next, there's a plan review option where typically, in the way that I was discussing it, you would do a review after you've done the work, but you can also have specialized reviewers review the plan itself. And then finally, there's a work step here, which you can use to begin the work. And so what I'm going to do is actually ask for, well, let's take a look at the plan. Maybe I'm happy with the plan as is. Maybe I want to deepen it a little. And so the plans all get written out to this plans directory. Here's the plan. So I'm going to read through it. We want to enhance the static system prompt, create an enhanced system prompt that incorporates condensed knowledge from the extracted book content, structures information in XML tags. So that's usually good for LLMs. Uses progressive disclosure, structures information in XML tags, uses progressive disclosure, and follows Anthropic Claude 4 best practice. Okay. Yeah, you know what? Very good. It looked pretty good to me already. I think that the way that we should do is to just do the work, and then we'll come back and review it later. So start work with workflows, work on, or actually, let me just show you what this looks like. So we'll do that. Okay, so it's loaded compound engineering. Now with the skill, it's going to go again and read through everything, and it's reading through all the materials. I don't know why I can't read that. Ooh, it hit compaction. All right, so let's do a thing. Do this, Claude DD, workflows, work, and then the plan file is this one. So let's see if it can do that without hitting some context limit. Okay, so it's asking us, should we go on a work tree or a feature branch? Let's say a feature branch. 2, yes, in German. 3, yeah, prioritize being comprehensive first. 4, don't worry about testing for now. We'll just YOLO it. All right, so we're going to check out a feature branch, which is a good practice when you're working as an individual developer, but Claude Code does that automatically. And now you can see it's created this sort of to-do list, and it's just going to go through like every single thing, and then it's going to create a better system prompt. So let's see if it can do it without hitting this token limit and hitting compaction points. Let's see how well it can do. All right. So we've identified a problem here, which is that in the process of reading this stuff, we are reaching this compaction point because like that has a ton of tokens already, right? And so the way that we should approach this is to perhaps make a new plan. And so let me think. Like we could basically do one after the other. Let's see. I made a plan here. The problem is that when we implement the plan, we sort of hit a point where just by reading each of these kind of still giant extracted components, we reach auto compaction just in the act of reading everything. And so what I am thinking is we could have like a modified plan in which uh, the goal is perhaps on separate work trees to use a modified, which applies just like one of the constituent pieces, whether part of a CSV file or one of the book extracts, to thinking about how to modify some piece of the plan. Sorry, you have the system prompt, like separate subagents or something. What do you think about that? And then we come back after it's done and like you take all these work trees and then just, combine them together in a sort of one big congealed prompt. All right, so I'm like kind of ad-libbing. This is a little bit more of an advanced technique, but that's why I get paid the big bucks, right? Be able to wing it just like this. I understand the problem perfectly. You bet you do, you motherfuckers, because I explained it to you perfectly. You have 8 source files, and just reading exhaustive context before any synthesis can work. Your proposed solution is essentially a map-reduced pattern for prompt engineering. That's correct. Each sub-agent gets one source file, reads it. Yep. Writes to a standardized output file. Reduce. Yep. This is clever. You bet it is. I came up with it. Yes, let's do it. All right. So we're going to create 6 Git work trees. Like, it's going to be 6 independent repos on which there's going to be some sort of attempt done to modify our system prompt. And then we're going to come back together and sort of bring them all together. Once we bring them all together, we will use the actual review step of compound engineering. But unfortunately, my demo, because of the complexity of this particular task, has had to go outside of what is traditionally done in compound engineering. All right, so it completed. There were 6 sub-agents that got triggered, and each of them made suggestions of what to add, and like that's the number of tokens that's in the suggestions. This symptoms explanations seems to be the most token heavy. And here, something interesting is that we only have 4% left before auto compact. So we were able to finish this, but it was still a pretty token intensive process. So when you're doing these really token intensive processes, it's important to find ways to break up the task as much as you can and make sure you write out your intermediate inputs. That's very important. All right, so we've got this new gigantic system prompt created. It's 17,400 tokens. I think before it was just like 600 to 800. We've included all this information from this CSV file and this book. So it is pretty extensive. Now, the piece that I'm not going to be able to do easily, well, we can try it. Let's try doing some QA and just see what we get. It's saying 6 work trees still exist if you want to clean them up. Yeah, clean them up now and then commit and push the changes. All right, so we've done plan, we've done work. Now, what I want to do is review the current PR. So what's going to happen now at this review stage is it's going to check what branch we're on. And then what it should do is spin up a bunch of different separate review sub-agents to review the changes that have been made. All right, so we see that a total of 6 review agents are now in process. So let me kind of walk through them. This one does sort of a review of the quality of TypeScript, making sure that you're correctly using types and following best practices with TypeScript. This one checks for security. This one checks for the architecture of like all the changes you've made together. Do they fit together? This one assesses performance. So that's more like if you have some kind of queries, then it'll check if they are efficient. This one looks for kind of code duplication or ways in which you can maybe use something that you're already using somewhere else in your code. And this one just tries to simplify everything as much as it can. Now, me personally, the ones that I like the best are Kira TypeScript, architecture, and pattern recognition. And the one that I like really hate is code simplicity because I find that it always just oversimplifies things when what I need is something like fairly complex, whereas what Kira TypeScript for whatever reason often does, and some of these others like architecture, when something does actually merit simplifying, they'll catch it anyway. Whereas this like piece of shit just always decides to oversimplify things. So I don't like that one. All right. So the 6 sub agents have finished their reviews. And then what happens is we get kind of a assessment of everything that was found. So there are 1, 2, 3, 4, 5, 6, 7, 8 findings. And now it's my responsibility. So this is like the human step in reviewing to decide, are these like real things that we have to deal with or are they kind of overstated? So that's what I'm going to. And so what it's doing is writing out each of these. And then what I'll do is go one by one and basically decide, yeah, let's make that change. No, let's not make that change. Yeah, let's make that change, and so on and so forth. All right. So let's see about this. Can't deal with that. It's suggesting prompt caching helpful for safe. Well, I think that's probably a good idea. I can ignore that kind of thing. Ignore number 2, some duplicate content. All right, so let's deal with 1, 5, and 6. Ignore 2 and 4. Let's deal with 1, 5, and 6. And then we'll come back to 3 still before merge. Yeah, so this is what reviewing looks like. You just kind of go through sort of you making some decisions, the AI making, but it's a symbiotic relationship. So it's best at doing some things and you are best at making other kinds of decisions. All right. So our work on these reviews is done. I basically decided that these 3 were okay. And then there were 2 others that were just totally irrelevant. So I ignored them. But this one, which the AI found, would be cheaper. In fact, with my expectations pattern, it might be more expensive because prompt caching is a technique where, like, if you want to put an entire book or a long thing in your context, and then you're going to use the LLM with that long thing in your context again in a very short period of time, then with prompt caching, you can basically like not pay for that big piece as long as you use it again in the next 5 minutes. But based on the usage patterns that I actually expect my client to use, he might like end up paying more by using prompt caching than without it. So I'm just cutting it and then I'll tell him, hey, look, it's going to be a little bit more expensive than I expected. Yes, commit, and then push and merge the PR. All right, let's test this thing out. So I've got 2 test emails I'm going to use. One is from this guy who's telling me to fuck off. And I don't know, it's like something about how to get clients or something like that. So nothing to do with veterinarians. And this one's much shorter. Wade at Zapier, how fluent is your team in AI? Hey, Wade here. One of the things you realize. Okay. So let's just take that. Let's like copy it. Copy. Go here. Paste. Transformieren. I guess that's how you say it in Germanian. Okay, so we got the transformed version. Now let's ask Claude Code to translate this. Can you translate this for me? I'm testing out the tool. Hey, I know you've probably called many vets, and yet your dog is the problems remain. Truth is not simply you need to understand what's happening. I see this with dog owners on a simple scale. It's pretty good, right? These were concepts in his book. Yeah, it's good. Now let's try this one. Fuck off. Okay, go here. Transformieren. Interesting. Let's take a look. Copy it in. How about this one? Cold calling vets is the best way to help your dog understand the root causes. All right, interesting. There's probably room for improvement here, but it's not something I'm going to be able to figure out without a lot more testing. But this was quite interesting. Yeah, so that's it for our demo of compound engineering. Now, if you really want to supercharge your abilities with Claude Code, what you'll need to do is start to make your own skills rather than just depend on ones that others are making for you. And if you want to learn how to do that, you're in luck because I've made a video exactly on that topic. So would definitely recommend you check that out next.